Okay, imagine a computer that doesn't just calculate one answer, but instead it calculates every possible answer, all at the very same time. Now, that might sound like science fiction, but it's not. It's the very real promise of quantum computing. And believe me, it's a technology that's poised to redefine what's even possible. So today we're going to break down exactly how it works.
All right, first things first, you kind of have to forget everything you know about traditional computers. See, a quantum computer isn't just a faster version of your laptop, it's an entirely different species of machine. While your computer uses bits to solve problems one step at a time, a quantum computer uses something called qubits to explore this huge landscape of possibilities all at once. It's a total revolution in how we even think about information. So, to really get this quantum leap, we first need to take a quick look at the building blocks of computing as we know it today. And that all starts with the simple, reliable bit.
You know, every single computer you've ever used is built on this one simple idea, the bit. A bit is basically just a light switch. It can be on, which we represent with a 1, or it can be off, which is a 0. That's it. Every amazing thing your computer does is just a combination of billions of these tiny little switches flipping on and off, really, really fast.
But now we enter the quantum world. In this world, the bit has a counterpart called the qubit. And even though the names sound similar, the qubit does not play by the same rules. In fact, it pretty much shatters them completely.
So how can a qubit be so different? Well, it all comes down to a really bizarre but fundamental principle of quantum mechanics. So get ready to have your mind bent a little, because we're about to start thinking beyond just simple on and off. The principle is called superposition, and what it means is that while a classical bit has to be either a 0 or a 1, a qubit can exist in a combination of both of those states at the exact same time. It's not one or the other, it's a whole spectrum of possibilities happening at once.
Let's go back to our light switch analogy. A classical bit is that normal switch. It's either on or it's off. Simple. But a qubit is more like a dimmer switch that's also kind of a ghost. It can be fully on or fully off, or it can exist in this strange ghostly state of being both at the same time. And this ability to be in multiple states at once is the first big secret to a quantum computer's incredible power.
And, as if that wasn't strange enough, there's another quantum trick that qubits have up their sleeves. It's a phenomenon so weird that even Albert Einstein called it spooky action at a distance. Let's talk about entanglement.
Okay, imagine we have two special quantum coins. So step 1, we link them or entangle them, which means their fates are now tied together. For step 2, we can separate them by any distance at all, across the room or even across the galaxy, it doesn't matter. Now for step 3, we look at or measure one of the coins, and let's say we find that it's heads. Well, here's the magic. Because they're entangled, in step 4, we instantly know the other coin must be tails. It's this instant, spooky connection, and that's entanglement.
So, here's the key takeaway. Superposition lets each qubit hold multiple values at once, and entanglement links them together so they act like one single, incredibly powerful system. When you combine those two things, adding just one more qubit to the system literally doubles the computer's processing power. This creates an exponential explosion of power, allowing a quantum computer to explore millions of solutions at once, while a classical computer is stuck checking them one by one by one. Okay, so all this theory is super cool, right? But what's the point? Why are we building these incredibly complex machines? Well, the answer lies in the kinds of problems they can solve, problems that are currently impossible for even our fastest supercomputers.
And we're not just talking about making your video games run a little faster. We're talking about solving problems that are fundamental to humanity. This ranges from designing life-saving new drugs and revolutionary new materials to creating incredibly sophisticated financial models and just supercharging the field of artificial intelligence.
Let's just take medicine, for example. The human body is this mind-bogglingly complex system of molecules. A quantum computer could simulate these molecular interactions with perfect accuracy. What that means is we could design and test new life-saving drugs inside a virtual space, accelerating discoveries that right now can take decades. I mean, it would be a complete and total game changer for human health.
So, where does all of this leave us? Honestly, it feels like we're standing at the dawn of a new technological revolution, just looking out at this vast and exciting new frontier.
Now, it's really important to be clear here. We are still in the very, very early days. Building and controlling these machines is incredibly difficult. But the progress is happening fast. We are at the very beginning of a journey that really does promise to reshape science, technology, and society itself.
What we're doing is building a tool that speaks the native language of the universe itself. The potential isn't just vast, it's probably beyond what we can even imagine right now. So the real question isn't if this is going to change the world, but just how profoundly it will. What currently impossible problem will be the first one to fall? What truly mind-boggling discovery will we make next?